Hello everyone, so let's talk about LFU cache. So this question is really hard, and if you didn't do the 146 LRU cache, then you should probably have to do it first. And if you didn't know how to do it, you can watch the video, and they just dive into the questions. So you need to implement a class, which is LFU cache class. So in this class, you have constructor and get method and put method, and this is pretty standard LFU definition. So if you didn't understand it, you just have to read it by yourself. And the most important thing is the minimum frequency of that application you are using. So that is the key point. So before I code it, I have to show you a diagram. So give this guy credit. It's a Mandarin LeetCode website, but I'm just telling you like what's the difference between the LRU and LFU. So this is LRU. So you have a HashMap, and you have key and value. For each key is the key, and each the value is the node. That node stored in the key and value. All right, so that will be it for LRU. So for LFU, right? For the LFU cache, you need a frequency map, which is this one. You also need a LRU map. So this is pretty similar. Like you just have to know if this node is currently using on this frequency. So this will be frequency 1, 2, and 3, and 4. So if I use this key once, so it will link to the list of the frequency 1. If a key used twice or 3 times, right, that will definitely be on this list or this list. And you also need to store the minimum frequency of this node, because when you want to add an extra node greater than your capacity, then you have to get rid of the minimum frequency node, then add a new node into the frequency map. So that would be pretty much and this is a GIF. So you will just see how they actually move from frequency map to from one frequency to another frequency count. So this is how it is, and you can just visit this website, and let's just start coding. So what I would do is I have to create 2 classes. One is doubleLinkedList node. So I'm gonna create a node. So in this node, I have an in key and value, and also frequency. And I also need the next and previous, which will determine my previous and next, right? And I'm going to have a constructor, and I'm going to say in key in val. So this.key equal to key, this.val equal to val. Frequency will become 1 no matter what for constructor, right? If you generate a node, right? If you generate a node, the frequency is 1, right? And the next and previous is definitely no. So previous equal to no. All right. Now I need another class which store the number of node, right? So I have to create a double linked list with a double linked list node. So I'm gonna say class double linked list. So that would be my class. So what will I do? I have a node for head and node for tail, and also the size. So if the size of this link is equal to 0, right, I'm going to delete this link. So this is how it is. So I'm going to have a public double linked list constructor for sure. So I'm going to declare my head and tail. So new node equal to 0, 0, tail equal to new node 0, 0. And I need to connect with name, right? So head.next equal to tail, tail.previous equal to head. So that will be the constructor. So I have several methods. So I'm going to type it up. So I have to add to the head, right? So add a node to the head. So that would be my one of the method. And public void remove the node. So no. and also remove the tail. So when I remove the tail, I need to pass return a value, so which is the node. So what are lists doing? So add the node to the head, which means if I already have this node in my list and I call it again, right? So which means I have to update my frequency. So it could be a new frequency, right? It will definitely update the frequency for sure, right? So you have to update the frequency to the head of the list. So this is how it is. And remove the node, that is definitely mean if I want to add an extra node greater than your capacity, if the size is already equal to capacity and I have to add a node into the list, and that will have to remove the node, and you just have to remove it. And remove the tail is definitely mean like this will be the least frequency that I'm in the that I have in the list, then I just have to remove. So what are you supposed to do for add the node to the head? So you will definitely need so this is your head and blah blah blah, this is your tail, and for x, y, and z, right? This will be your x will be your head, and okay, this head and this tail are dummy head and dummy tail. You are not using it, but this x is your head. So what you will have to do is you have to generate a new head. I'm going to call it A. A will become your head, and you have to connect the double linked list direction to each other. So that will be a simple data construction for sure. So I have old head equal to head.next, and node.next is equal to old head, right? And node.previous is equal to head. So I'm going to, so A will become my node. So I'm going to connect the old head and head, right? Then I need to know. So I already get rid of these two, right? Then I need to redeclare these two direction. So that will be head.next is equal to no, and old head.previous equal to no, right? And size plus plus. When you add the node into the list, you increment the size, right? So that would be the idea. So remove the node. Remove the node is actually simple. So since it's not the tail, right? So I'm gonna have, so remove the x, y, and z. So for example, you want to remove y, but since you have the direction for x, y, and z, right? You need to know if you want to delete y, right? If you want to delete y, you need to redeclare the x and y for these two directions. So that would be simple. So let's just start coding. So I'm going to say previous node equal to node.previous node next node is equal to node.next, and the previous node.next is equal to next node, right? And next node.previous is equal to previous node. So did I spell it wrong over here? Yes, I do. So that will be it. But once you remove the node, you need to decrement the size. All right. And how about the tail? Tail is simple. So I don't have to remove the, okay, I don't have to decrement the size again, because when I remove the node, I already know I decrement the size. So I don't have to say, okay, now you want to remove the tail, you just decrement. So I'm not going to do this over here. But if the size is greater than 0, right, which means there is something inside. So this is head and blah blah tail. So if you have z at the end, if you want to delete it, right? So I'm going to call it no equal to tail.pre, and I'm going to call this function remove no function. So remove no, I'm going to call it no, and I'm going to return no. So I already decrement the size inside my remove no function, so I don't have to decrement again. And if the size is greater than 0, then you just do this. else return null. That will be it. And so if you know these two classes, that will be super standard. So let's start coding for the main class, LFU cache class. So for LFU class, you have frequency map, key map. Key map is actually your cache map. So I'm going to say cache over here. And size, and minimum frequency, and capacity. So let's just start coding. So I have the final int. So capacity will never change, right? And I do have the minimum frequency and the size. And I do have the hash map to store my frequency and cache. So I'm going to create my cache first and double linked list frequency map. So I'm going to tell you again, I'm using my double linked list for my frequency map because the frequency map key will store the frequency number and the value is the list of the frequencies list. And the cache is actually store your key, right? And your nodes. So that will be it. So for the constructor, right? You just have to declare. So how you actually declare is list of capacity equal to capacity. Size is equal to 0. Minimum frequency is equal to 0, right? And to map, right? Cache equal to new hash map. Frequency map equal to new hash map. So that would be it. So if I need to implement these two methods, I need another helper function, which is called update node. So I'm going to write down first, and I will tell you later. Update node. No. So what you have to do inside this get method. So if a node exists, update the node. Otherwise, -1, right? So I'm going to say no. I'm storing every single node into my cache for sure, right? So I'm going to say cache.get.key. If the node is equal to null, so if you cannot get the key inside your map, right? Then it's supposed to be null, right? Then I just have to return -1. Okay, if I do get a null, I need to update the node. So how do you update a node? That would be another story. And I will just return node.val. So if you get a node, you just have to return the value, right? This is how the get method works, right? So that would be standard. And how do you update a node? So for your update a node, you need to delete the node inside your frequency map first, and also add the node to the new frequency count list. Okay, so if I have to type it out, I will definitely say delete the node frequency inside is this, and increment, then add it to the new list with its frequency list. Okay, I mean, you get the idea, right? So let's just start implementing. I'm going to say int freq equal to node.frequency. And I'm going to get a list of it, right? New linked list. I'm going to say list and freq map.get, and that will be the node.frequency. So which is frequency, right? And I have to remove the node inside this list, right? I need to remove the node inside this list, and I need to update, right? Update to the new list. So here's the trick. If this node is the minimum frequency, right? If this node is the minimum frequency, when you increment it, doesn't mean the minimum frequency incremented as well. So if the frequency is equal to minimum frequency, I do have a minimum frequency to keep counting the frequency, right? And also the size is equal to 0. So what do you actually mean the size is actually equal to 0? because in the list, right, if you are the minimum frequency and also inside the list, then when you delete it and the size become empty, right? Which means you no longer need this list for sure, but you also need to update the minimum frequency. So that will be minimum frequency plus plus. This is why, because you will definitely update your frequency over here. And that will be it. So if you update the frequency, then just get a new list. Let me say new list equal to frequency map.get. So since you are generate a new list inside your frequency map, right? This list could be generated first or does not, right? So you can actually use the one way for node.frequency. If the key exists, then you just get a node.frequency. If the map does not get it, then basically you just have an empty linked list map, a linked list. So am I spelling it right? All right. And also, when you have the new list, right? Come on, where is my mouse? If I have the new list, then I have to update? Sorry, I have to add a list. Actually, add a node to my list, right? So that would be it. And just at the end, you need to know you have to add a new list into your frequency map. So I would say frequency.map.put, and there will be a frequency count, so which is node.frequency with your node, right? And that would be it. Okay, so this is new list, sorry. So you have to add your frequency into a key. Value is your list, so should be new list. Sorry, I made a mistake over here. And for your put, right? When you want to put something, if the node exists, update the frequency count, else create a new node. Okay, this will be a little bit longer, but I'm trying to make it short, all right? If the capacity is equal to 0, so if you generate, for example, if you look at it, if your size is equal to 0, whatever you put, you are not going to put into your map because this is not allowed because your capacity is 0, right? So I'm going to say return. And also, if the cache.contain key, if you do have this key inside your map, then you just update the node value, right? So I'm gonna get the value, cache.get key, right? And node.val is equal to value, and I need to update the node. So since I'm calling this again, I need to update it. So I'm going to say update the function, and then that will help you to generate my new frequency count list. So if I didn't find it, I need to generate a new node. So if I have to generate a new node, doesn't mean I have to increment my size. So that will increment my size. It will keep counting how many nodes inside my map. And if the size is greater than capacity, I need to delete the least frequency node inside my frequency map, right? So doubleLinkedList, I'm gonna call list. Okay, list. So frequency map.get minimum frequency. So this, I already stored the minimum frequency, so I don't have to find out which one it is. Just you can just type frequency map.get minimum frequency. So I'm going to say no, and this node is definitely going to be deleted, right? So I'm going to say delete node will be list.remove, and this will definitely at the tail, because if you are not using it, it's definitely at the end of the list, right? So that will be a remove tail, And remove tail is actually over here, right? You remove the last one, which you are not using. I mean, which you are using the minimum frequencies, right? So at the end, you delete inside your map, inside your list. Then you also need to delete inside your cache, which is cache map, right? Delete no dot key. And if you delete, just minimize size, and that will be it. So if the size is not greater or equal to it's not greater than capacity, which means it's invalid capacity, then what you actually need to do is you can know your minimum frequency is equal to 1. There's a reason why, because you generate a new node inside your map. So which means there will be a new node with the frequency 1, because you just generate, you just create it, right? And I'm gonna say new node equal to new node with your key and value. So if I have the new node, I need to have the new list, right? And I'm gonna say new list equal to frequency map get or default. So that would definitely be 1, because you just generate. If the map did not create, does not have a key of 1, you just have to declare a double linked list. So frequency map key is frequencies count, value is the linked list, double linked list. So if you just create it, then you need to add the node to the head with the new node. So at the end, you need to update your frequency map, right? So you're going to put the frequencies count, which is 1, the list, new list, and also the cache that put key with the new node. And this will be the solution. And they just run it. I know this is a little bit long, but I spent 2 days working on it, so there will be a problem. Okay, I have a problem here. So did I spell it wrong? Yes, I do. And I hope I don't have error. Okay, I do. So new, okay, I know why I spelled it wrong again. Okay. Okay, what happened? 98 capital O, okay. So all of it, please. Yes. All right. So that will be the solution, and they just see, do I pass? Yes, I pass. So for the time and space complexity, I'm not going to explain, because this is just telling you how to write a function for get and put. And if you really want to know the size, the complexity, I would say time is all of 1, and space is all of n, right? And I mean time. I mean when you find it, when you get and put, that is just all of 1, right? And for space, you need to generate a node into your map, and then that would be all of n. And that would be the solution. And if you have any comment, please comment below. I know this is long, and if you like the video, please press a like and subscribe if you want it. All right, peace out. Bye.